So hello friend, this is Kaustup Pathare again with a new video. So today in this video we are going to learn the logarithmic differentiation. So let's start the video. So before moving to the logarithmic differentiation, look at a particular function. We will study how to differentiate in logarithmic function. Let's say we have y equal to x raised to x in this case. So in order to differentiate this function, we have to take you have to use the property of logarithm. So by using the property of logarithm, we have to take the log on both sides. First, take log on both sides. Okay, so after taking the log on both sides, we have log y is equal to log of x raised to x, log of x raised to x in this case. So according to the property of logarithm, we have the function as log of x raised to x can be expressed as log of x raised to x equal to, as we know that log of x raised to x is equal to x log of x in this case. So power comes in the front. So log y equal to x log x in this case. So x will come in the front in this case. So first we have to differentiate with respect to y. So differentiating with respect to y, we get differentiating with respect to y, we get as the function as with respect to x, or with respect to y we get the function as, if we differentiate a particular function with respect to x, so the y will remain as it is, and we have to maintain a dy by dx at that particular point. So as we know that the derivative of log function is log of f of x or f of y or anything. So log of f of x, the derivative of log y with respect to x in this case is 1 divided by y, as 1 divided by y dy upon d of x of dy upon d of x, which is equal to the derivative of, means d upon d of x of log x, d upon d of x of x log x in this case, which is equal to, so first we have to use the chain rule for differentiating this function. So as per the chain rule, we have to differentiate, first we have to differentiate x and we have to multiply it by log x. Then we have to make an addition operator, take the add function, and then we have to differentiate log x and multiply it with x in this case. So let's start. So first we have to differentiate x. So the derivative of x will be 1. So I will write 1 over here. Then I will write by the step. So log x into the derivative d upon x of x is equal to log x into d upon d of x of x plus x into the d upon d of x of log x in this case, which is equal to log x plus x divided by x in this case, log x plus x divided by x in this case. So log x plus x divided by x in this case is equal to log x plus 1, which is equal to log x plus 1 in this case. So my dy by dx of, means 1 divided by y dy by dx will be equal to log x plus 1 in this case. Now this y will go in the numerator over here. So we multiply this y, this y, we have to multiply it by log x plus 1. So my expression will be equal to y into log x plus 1 in this case. So we have now the value of y. The value of y is equal to x raised to x in this case. So put the value of y. So it is equal to x raised to x into the log of x plus 1 in this case. So our final answer is x raised to x log of x plus 1. So this sum is just for the demo. So now we will start solving the more complicated sums related to the logarithmic differentiation. So let's start. So this is our first sum. So in the first sum we have square root of 2x plus 3 raised to 5 divided by 3x minus 1 raised to 3 into 5x minus 2. So first of all we will write, let us consider the y equal to this particular expression in this case. So if y is equal to this particular expression, taking log on both sides, so after taking the log on both sides we have, taking log on both sides we have log of y equal to log of the particular function, and then we have to simplify it using a logarithmic rule. So now we have to first use the logarithmic properties, which I have told you in the previous videos, in the logarithmic videos. So log of y is equal to log of the particular expression. So this is the first, we have first square root, then we have 5, and then we have 3, and then we have 1 as a power. So first we have take the power of square root in this case, so which will be equal to, the power will be equal to 1 by 2 in this case. So it will be 1 divided by 2, which is equal to, then 1 by 2 is my power. So I will write a note over here that if the power of any number, let's say log of a raised to b, a raised to b equal to b log a in this case. So same rule we have to use in this case for solving the sum. So my log of y, or log y, will be equal to, log of y will be equal to 1 by 2, 1 by 2. So the log of y will be 1 by 2 in this case, 1 by 2 log of this particular function, 1 by 2 log of this particular function. Now we will use the logarithmic, rest of the logarithmic properties, like this same property we are going to use, and then another properties like addition, subtraction. Okay, so log of, I will write the properties over here, log of a minus log of b equal to log of a divided by b, and another property is log of a plus log of b equal to log of a plus log of b equal to log of a b, or let's say a into b. So these two properties, and the upper property, this log of a raised to b, we are going to use in this case. So let's use it. So my log of y will be equal to, 1 by 2. So 1 by 2 I have taken as a common, because 1 by 2 is a constant, so I have taken outside. And because in the logarithmic property, the power in the logarithmic function goes to the front, or comes in the front. So here it is log of, the power is 1 by 2. So according to the logarithmic property, log of a raised to b is equal to b log a. The same property I have used over here. So 1 by 2 got come in the front. So 1 by 2 have come in the front. So 1 by 2 log of 2x plus 3 raised to 5, 3x minus 1 raised to 3 into 5x minus 2 in this case. So it will be 1 by 2. So it will be 1 by 2, 1 divided by 2 log of, so first of all we will use this property, log of a plus b in this case. So, and log of a minus b in this case. So first we will use log of a minus b. So put a square bracket over here in order to understand the property. So first will be log of 2x plus 3 raised to 5. So we will put over here log of 2x plus 3 raised to 5 minus log of, put another bracket, minus log of this particular function, log of 3x plus 1 raised to 3 in this case, 3x plus 1 raised to 3 in this case, plus, because it is multiplication, so log of two multiplicative two numbers is equal to the addition, and log of division, division of two numbers is the subtraction of two numbers. So means, understand that log of a minus log of b is equal to log of a divided by b, whereas log of ab is equal to log a plus log b in this case. So division of two logarithmic numbers is equal to subtraction of the individual logarithmic number, and the addition of individual logarithmic two numbers is equal to multiplication of that two logarithmic number according to the logarithmic rule. So we will to it over here. So here it is multiplication of two logarithmic numbers, as 3x plus 1 raised to 3 is multiplied with 5x minus 2, and also the division of two logarithmic number, as 2x plus 3 raised to 5 is divided by the expression in the denominator, which is this 3x minus 1 raised to 3 into 5x minus 2. So it will be 5x minus 2, 5x minus 2 in this case. So we will close the bracket and we will close the main bracket in this case. So my expression will look like this. Now we will use the property of logarithm in order to simplify it. So this property we are going to use, log of a raised to b is equal to b log a. The same property we are going to use over here. So which will be equal to log of y will be equal to 1 by 2 uh, 1 by 2 log of 2x plus 3 raised to 5. So 5 will come in the front and 5 into the log of 2x plus 3 in this case, and then we have to use the minus sign, and then we have to open the brackets. So here it is 3 log of 3x minus 1 raised to 3. So 3 will come in the front, so 3 log of 3x minus 1 minus log of 5x minus 2 in this case. So now the expression will look like this. So now we have to differentiate it using the derivative operator. So my dy by dx of the particular function will be equal to dy upon d of x of log y, which is equal to d upon d of x of the combined function 1 by 2. I will take it as outside because it is a constant, so I will take it as outside, and my dy upon d of x will be equal to this entire function, so which will be this. Now we have to differentiate, so let's differentiate one by one. So first of all, differentiate log of y. So my log of y will be equal to 1 upon y dy by dx, 1 upon y dy by dx, because I have used here dy by dx because when we are differentiating with respect to x, so and we have a y function in it, so we have to put dy by dx. For if we are differentiating y with respect to x, but we are differentiating with respect to x, but we are differentiating y. But in case we are differentiating with respect to x and we have the x variable, no need to put dy by dx. But we are differentiating in y variable and we are respect to x, then we have to put dy by dx in this case. So I will put dy by dx, which is equal to 1 by 2 and the derivative of this function, so which will be equal to 5 divided by log of 2x plus 3. As we know that the log of any number or the derivative of any log function is 1 by x, so log of 2x plus 3 will be 1 upon 2x plus 3 into the derivative of 2x plus 3, means the derivative of 2x plus 3 we have to put over here. So I will write d upon d of x of 2 raised to 3, d upon d of x of 2x plus 3 in this case, minus 3 divided by log of 3x minus 1, 3 divided by log of 3x minus 1, 3 divided by log of 3x minus 1 in this case. So 3 into the derivative of this, so it will be d upon d of x of 3x minus 1 in this case, and then we have to take the differentiation of the another function, which is equal to 1 divided by log of 5x minus 2 into the derivative, 5 of log of 5x minus 2 into the derivative of 5x minus 2 in this case. So the same operators or the same functions we have to use in the case of logarithm. So we have to differentiate it one by one considering the differentiable factors. in this case. So now we'll close the bracket, and now it will look like this. So let's come to the final answer. So 1 upon y dy by dx, we have to write it as it is, equal to 1 by 2 and the derivative of this function 2x plus 3 gives me 2x. So I will write here as derivative of 2x plus 3 gives me 2x. So I will write here as 5 into 5 multiplied by 2, because the derivative of 2x is equal to 2 in this case, minus 3 upon 3x minus 1, minus 3 upon 3x minus 1 into the derivative of 3x minus 1. So the derivative of 3x minus 1 I will get here as 3 in this case, because the derivative of 3x is 3 and the derivative of 1 is constant, so minus 1 is constant, it will be 0. Now we have to take the derivative of 5x minus 2, so this will remain as it is, and then I will take the derivative of 5x minus 2. The derivative of 5x will be equal to 5, and the derivative of minus 2 will be equal to 0 in this case. So the derivative of 5x will be equal to 5 and the derivative of minus 2 will be equal to 0. So my expression will look like this. So which is equal to 1 by 2, which is equal to 1 by 2 into the bracket of this particular function, and this will be my answer. So 5 into 2 gives me 10, and 3 into 3 gives me 9, and 1 into 5 gives me 5. So this will be my answer, and then I have to do one thing. I have to multiply this y in the denominator with this expression. So in the next step, my dy by dx will be equal to, so my dy by dx will be equal to this particular function, dy upon d of x will be equal to y multiplied by the particular function. So now we will resubstitute the value of y. So we will come over here in the upwards position. So we know that the y is equal to this particular function. So copy the function and then resubstitute the value of y over here. So instead of y, we will put this function, and this will be my complete entire final answer of the derivative of square root function, square root of 2x plus 3 raised to 5, 3x minus 1 raised to 3 into 5x minus 2. So in this way you have to differentiate the logarithmic differentiation. So I will write a note over here as my y will be equal to the entire function. So my dy by dx is equal to this entire function. So in this way the other differential functions we have to differentiate, and we have to, this is a quite easy simple answer, but the more complicated related differentiation you have to do by yourself. So if you like my video, please share, subscribe and comment on my YouTube channel Making Maths Easy. Thank you for watching.